Good day, students. In this clip, we're going to be going over two examples on how to graph our transform trig functions. So the form that we're going to be looking at are sine and cosine trig functions of the form y equals a sine b x minus h plus k, or y equals a cosine, the same thing, b x minus h plus k. Okay, so for the two examples we are going to do, you're first of all going to find list the properties, and then the properties of the trig functions in these two forms are as follows. I'd like you to state the new origin. The new origin is given by h comma k. Then I'd like you to state the phase shift. The phase shift is given by the x-coordinate of your new origin, which is h, and also indicate the vertical shift. The vertical shift is the y-coordinate, which is k. And then you state the amplitude. The amplitude from this formulation right here is the absolute value of a. Okay? And then the direction of the amplitude is up or down from the central position. And then you state the period. The period is given by 2 pi over the value of b. Okay, and also be sure to indicate that 4 ticks in your calibration of the x-axis is going to be equal to your period 2 pi over b. All right, and then the other property you have to state is the frequency. The frequency is basically the reciprocal of your period, and then that's given by b over 2 pi. And then lastly, before you plot the graph, I'd like you to state the window that your graph is going to be created on. And then for the window, you just start with the new origin, h comma k, and then you're going to go 1 period to the left, so plus 2 pi over b, and then 1 period to the left, 1 period to the right, negative 2 pi over b, by the value of your period. And then you're going to go up and down along the y-axis by the value of your amplitude. So plus minus a goes on the bottom, minus the absolute value of a, and then to the top plus the absolute value of a. Okay, so that will be the setup for your window. All right, so in this case here, you're going to have h plus 2 pi over b. That's how far you go to the right, and then to the left, h minus 2 pi over b. You're going to go up k plus the absolute value of a, and then you're going to go down k minus the absolute value of a. All right, this helps you set up your window so you can graph your function with ease. All right, so let's take a look at the first example. Question number 1. What if we have the trig function given by y is equal to 3 sine 2 times x minus pi plus 2. Okay? Alright, so let's start off by finding the new origin. The new origin is given by hk, but what is h and what is k here? So let's write down the formula, the main formula that we wrote up here. Let's rewrite it here again so we can know what the letters are. So we have y is equal to a sine b times x minus h plus k. Okay, we can see that a is 3, b is 2, h is pi, and k is 2. So the new origin is hk, which is given by pi, comma 2. All right, so that means that our phase shift is going to be pi units to the right. Okay, and then our vertical shift is going to be 2 units up. All right, and then amplitude is going to be the absolute value of A. So amplitude is going to be the absolute value of A. We can see that A is 3 here, so absolute value of 3 is simply 3, and that's going to be 3 units up and down from the new origin. Next thing we need to find is the period. The period is given by 2 pi over b, and we can see that b here is 2, so 2 pi over 2 is equal to pi. Alright, so this tells us that in our calibration, 4 ticks on our x-axis is going to be equal to pi units. Alright, so let's keep that in mind. And then we have your frequency. Frequency is the reciprocal of the period. Period is pi, so the frequency is 1 over pi. Alright, before we set up the graph, let's set up the window that we're going to use to determine how far we're going to go in all 4 directions. So the center is pi, comma 2. That's the new origin. We're going to go a period to the right and to the left. So period to the right, we're going to add pi to the x-axis. If we add pi to the x-axis, that takes us to 2 pi. And then a period to the left, we're going to subtract pi from the x-axis. That will take us to 0. All right? And then up and down, going up, we're going to add, what's the amplitude? 3. We're going to add 3 to 2, which takes us up to 5. So our y-axis is going to go as high as 5. And then we're going to subtract 3 from our y-axis. Our y-axis is going to go as low as -1. All right? So this window is what we're going to look at to set up our graph. All right, so let's go ahead and set it up. We can see that our center is in the first quadrant. All right, so let's do our coordinate system. Since we're in the first quadrant, we'll just shift the x-axis to the left a little bit, and then shift the y-axis down, because we're just going as low as -1. So you can put the y-axis over here. All right, so let's see. We are now going to, by our x-axis, we're going to start by calibrating our x-axis. So to calibrate our x-axis, we're going to look at the period. It tells us how to do that. Is in terms of pi, so we're going to go by pi. So 4 tick marks is going to be pi for us. So let's go 1 on the x-axis, 1, 2, 3, 4, that's pi. How far are we going to go? We are supposed to go as far as 2 pi, because that's what we found out in our window. So we're going to go another 1, 2, 3, 4, and that's 2 pi. Alright, so that's the calibration of our x-axis. Now for the y-axis, we're going to go as high as 5 and then as low as -3. So 1, 2, 3, 4, 5. That's going to be our maximum. And then as low as -1, 1, and -1. That's it. Okay, so -1 and then 5. Alright, so there goes your y-axis. Now let's graph our new origin. Our new origin is at pi, +2. So this is pi, +2 is 1, 2. Alright, now we're going to graph our new or translated coordinate system. So this is the our new y-axis right here. The new y-axis. And then our new x-axis is going to be right here. We're going to go as high as 5, so this is the maximum. And then as low as -1, and that's your minimum right here. How did we find that? We use the amplitude, because the amplitude indicates that we are going to go 3 units up and down from the central position. Alright? Alright, so what function are we graphing here? We're graphing the positive sine function. And we remember what the orientation of the sine function is. The sine function looks like the s's from the center. Sine function basically looks like the s's for sine. That's a positive sign. And then the cosine function is like the cups. Okay, so you want to keep that in mind. So this is the format that we're going to be following. We're going to start from the center, the new origin, because we know that's where sine starts from. So we're going to go one tick mark takes you to the maximum. One tick mark takes you down to the center. One tick mark takes you to the minimum. And one tick mark back to the center. So that's one complete period in the right direction. And one complete period in the backward direction. One tick mark back takes you to the minimum. One tick mark center. One tick mark maximum. One tick mark back to the center. And this pattern basically continues forever. Alright, so let's go ahead and connect the dots. So just draw your sine curve as best as you can. Connecting the dots. Like that. Try to curve at the max and the min and straighten out towards the center. And then this pattern continues forever. Okay? So there goes the graph of the original function. Alright, let's take a look at question number 2. So for number 2, we have y equals negative 3 pi cosine pi times x plus 3 plus pi. Okay, now we're graphing a negative cosine trig function. All right, now to find the properties, before I start finding the properties, let's go ahead and write down the general equation that's going to guide our determination of the a, b, x, and h and k. So we're going to go y equals a cosine bracket b x minus h plus k. Okay. All right. So let's go ahead and find what the properties are. Properties. Let's start with the new origin. Our new origin is hk. So our new origin is going to be you take the opposite of the number next to the x. Since you notice the signs do not match, negative 3, and then k is pi, negative 3 pi. So this tells us what our phase and vertical shifts are. So our phase shift is negative 3, so it's 3 units to the left. And our vertical shift is the y-axis. So since it's pi, it's going to be pi units upwards, and it's positive. Now let's go ahead and look for our period. Our period is 2 pi over b, so we know that b is pi, so it's going to be 2 pi over pi. So 2 pi over pi is going to be 2. So this tells us what the calibration of our x-axis is going to be. It's going to be 4 ticks is going to be equal to 2 units when we're calibrating our x-axis for graphing. Okay? All right, and then our frequency is the reciprocal of the period. All right, so our frequency is 1/2. Now let's go ahead and set up the window so that we can create a nice graph. So the center is negative 3 comma pi. We're going to be going a period to the right and left. So let's indicate that, a period to the right and a period to the left. So what is our period in this problem? Our period is 2, so we're going to add 2 to the x-axis to know how far we're going to go to the right. Negative 3 plus 2 takes us to negative 1. And then we're going to subtract 2. That takes us to negative 5. So that's how far to the left we're going to go. Up or down, that's our amplitude. Values we're going to be adding to the y coordinate of the new origin. All right, so what we're going to do is add, let's see, what is our amplitude? Oh, we forgot to find it. So let's find the amplitude. Sorry about that. The amplitude is the absolute value of absolute value of negative 3 pi is just simply 3 pi. Okay, so to go high, we're going to add 3 pi to pi, and that takes us as high as 4 pi. And in our window, to know how low we go, we're just going to subtract 3 pi from the y coordinate. So pi minus 3 pi is negative 2 pi. Okay, so this window will help us determine how far we should go in all directions of our calibration. Okay, now let's draw our coordinate system. We can see that our graph is going to be centered in, the center is going to be in quadrant 3 since we're going, actually quadrant 2 since we're going to the left and up. All right, so let's see, we go out, and then since the x's are both negative, so we have to shift our y as far to the right as possible, and then put our x-axis somewhere beneath the center, since we notice that the negative value is smaller than the positive value. Okay, all right, so let's go ahead and calibrate our axis. Okay, so we'll start with the x-axis. We know that 4 ticks is equal to 2. So let's do that. We don't really care too much about the right side right here. Just go to the left. So we're going to have 1, 2, 3, 4. That's 2. And then how far are we going? All the way to negative 5. So let's keep on going. 1, 2, 3, 4. Now what is that? This is 2, that has to be 4. And then 1, 2, 3, and then that's 6. Since 4 tick marks is 2, that means 2 tick marks is 1. So this is going to be 5 right here. This will be these are all negatives, okay? This is negative 5, negative 4, negative 2, and negative 1 is going to be right here in the center, negative 1. Okay, how high do we go? All the way to 4 pi. So let's do that. 1, 2, 3, 4. Let's call that 4 pi. And how low do we go? All the way to 2 pi. 1, 2, negative 2 pi. All right. Okay, our center is at negative 3 and pi. This is negative 3 right here. Negative 3 pi is right here. Okay, let's draw our new coordinate system. So this is our new, our transformed x-axis, and this is our new y-axis right there. All right, now what we're going to do next is graph the max and the min. So the maximum displacement is 3 pi units from the center, which should take us to 4 pi as indicated on our window, and then 3 pi units down from the center, 1, 2, 3, will take us to negative 2 pi right here. Okay, we're now ready to draw our graph. What are we graphing here in this problem? We are graphing the negative cosine. So what does a negative cosine look like? We know that the sine is like a cup. It goes upwards, but what if it's negative? It's going to be like a cup that's flipped upside down, like that. So that's what the negative cosine looks like. Okay? All right, so let's go ahead and graph it. So since we're going to be starting from the minimum, because of the negative cosine, we'll start from this point right here in the center, right on your new y-axis, okay? Because your cosine always starts at the max or the mean of your y-axis. So we're going to start from the minimum. 1 tick mark over takes you to the center. 1 tick mark to the max. 1 tick mark back to the center. 1 tick mark to the min, and that's 1 complete period. You see 1 upside down cup takes us to negative 1. And in the other direction, 1 tick mark to the center, 1 tick mark to the max, 1 tick mark back to the center, and 1 tick mark back to the min. That takes us to negative 5. All right, let's connect the dots, and that will be our negative cosine. Remember, this pattern continues forever. Okay, so go like that, straight out of the center, curve at the max, curve out of the max, straight towards the center, straight out of the center, curve at the min, curve out the mean, straight to the center, straight out of the center, curve at the max, curve out of the max, straight through the center, and curve at the mean. And then that pattern basically continues forever. All right? So this is basically the graph of the function that was indicated above. But thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel and please post a comment to let me know what you think. And do give me a thumbs up if you like this, and feel free to share with your friends via your independent individual social networking program. Thanks again for watching and have a wonderful day.